Hey Opties! Today we're talking about midpoint. Midpoint. So a midpoint is a point on the middle of a line segment. We can talk about this in two main ways. So a definition of this is a point on a line segment that divides it into two equal parts. So thus it is the middle. The first way we talk about this is it can be out in the open, not on the XY plane, where we just talk about its division of length. So mostly we're just looking at its length. And this will be considered a Euclidean geometry look at midpoint. So let's write that. So this is going to be Euclidean. So a Euclidean look. Remember how we talked about Euclid being the father of geometry? Well, Euclid talked about geometry not really on the coordinate grid or the coordinate plane. And that brings us to our second way of looking at midpoint. It can be on the XY plane or in the XY plane with a coordinate pair showing its location where we calculate the lengths. So this is going to be looking at it as coordinate geometry. And let's just go ahead and write Euclidean geometry. Those are the two main ways we dissect geometry or separate them, and you'll be hearing those words throughout geometry. Let's take a look at the formula for midpoint if you're looking at it as coordinate geometry. So this can be used to find a midpoint of a segment given the endpoints of that segment on the XY coordinate plane. So here's a point to ponder. An average tells the middle of a data set. So when calculating a midpoint, we are finding the average of the 2 points. Now think about, what do you do when you find the average of data? Well, you add up all the data and you divide by how many elements of data you have, or how many pieces of data. So if you have 2 endpoints, you're going to add up your x's and divide by 2, and add up your y's and divide by 2. And that gives you the midpoint formula. So I have a little way for us to remember the midpoint formula. An average is also called a mean. So let's remember the phrase mean midpoint, or that midpoint is mean. So that's going to help us recall the formula. See, a little alliteration there. You're welcome. So midpoint, like we said, x1 plus y1. So you're adding up your x's and you're dividing by 2. You're finding the average of the 2 x values of this segment's endpoints. The same thing goes for your y values. You're adding up those y values and dividing by 2 because there are 2 of those. So where endpoint 1 is x1, y1, and endpoint 2 is x2, y2. So that's what these numbers are coming from. And here's the picture. So here's one of our endpoints, x1, y1. Here's another, x2, y2. And our midpoint is determined by that midpoint formula. Let's take a look at some practice. Number 1 says AB has midpoint, point C. Point A is at 2, 3. So let's go ahead and plot that. 2, 3. That's going to be point A. And point B is at -3, -4. So -3, -4. Here we go. And that's B. And I'm going to go ahead and write what A is beside it. 2, 3. Okay, find the location of point C. Okay, so that's the midpoint. Here we have a picture. So C is going to be somewhere around here. But we can't just go by eyeballing, right? That would be kind of like risky. We are not real sure where C is exactly, but just by looking. So what we can do is use the midpoint formula. So I'm going to do that first, and then I'm also going to show you how to do it by looking at your graph and kind of reasoning through it with the use of your graph. So let's do our midpoint formula. So midpoint equals, let's add up our x's and divide by 2. So 2 plus negative 3 divided by 2. So we're averaging our x values. Let's average our y values. 3 plus negative 4 divided by 2. Okay, so let's simplify this. 2 plus a negative 3 is negative 1, and we're dividing by 2, so negative 1/2 is our new x value. 3 plus negative 4 is a negative 1, and dividing by 2. So it's actually really cool because they match. And that's just a coincidence. But it's negative 1/2 and negative 1/2. And we plotted it pretty well. That was a pretty good eyeball. So that's going to be point C, and that's negative 1/2, negative 1/2. Now what you could do is think about slope. Remember, slope is the change in y divided by the change in x. Or if you're looking at a graph, we often say rise divided by run or rise over run. So let's look at the slope of this line. Let's find the rise. So the rise is going to be shown with this dotted line, and that's going to be the distance between your y values, or the change in your y values. So you're down here at negative 4 and you go all the way up to 3. So that's 4, 5, 6, 7. That's a positive 7 since you're going up 7 places. And to our right, we're going to go positive some number. From this negative 3 to the 2, that's a 3 to the y-axis, then a 2, so that's going to be 5. So what you could do is think, okay, well, half of this height is going to be the location of the y value of my midpoint. And half of this width is the location of the x value of the midpoint. So let's find half of 7, which would be 3.5, right? Now, that's not just the number 3.5. As you can see, your new y value is not 3.5, but it should be 3.5 bigger than your starting y value of this b. So let's check that. What's negative 4 plus 3.5? Well, that is negative 1/2. So that works too. Let's check the same thinking on our x change. So what's half of 5? Well, that's 2.5. So you should be increasing from the x value of b 2.5 places to get to this new x value of your midpoint. Okay, so negative 3 plus 2.5. Let's do that. Negative 3 plus 2.5. Well, that's also negative 1/2. So you can see how it works both ways. So whatever way works best for you, go for it. This method is also called partitioning a line segment, and we will do more of this later on in one of our later units. Let's take a look at number 2. Let's read it and then we'll start graphing. So point O, which is at 2, negative 1, is between endpoints J at negative 2, 1 and B at 4, negative 2, and collinear with point J and point B. Is point O the midpoint of JB, the segment JB? And how do you know, or how do we know? Okay, so it told us some info like it's collinear. So O is at least on the line, on the segment. So point O is at least on the segment JB. But we want to know, is it the midpoint? We know it's between as well, but just because you're on the segment and you're between the endpoints doesn't make you a midpoint. You have to be in the middle, right? So let's plot the points to just get a good look at what this looks like. So O is at 2, negative 1. So that's point O. J is at negative 2, 1. And B is at 4, -2. Okay, so we can see that O is not the midpoint because visually it's closer to point B than it is to J. And if it was the midpoint, it would have to be equally away from both of those endpoints. So that's one thing we could say. We already know that no, point O is not the midpoint of segment JB, since point O is closer to point B than it is to point J. But we could also check to see if it works with the midpoint formula. So let's do that as well. So we want to see if adding these two x's and dividing by 2 and adding these two y's and dividing by 2 makes the point 2 -1. So -2 plus 4 over 2, that is the average of our x values. And let's take a look at our y's. So 1 plus -2 divided by 2. And the question is that equal to point O, which is 2 -1? So -2 plus 4 is 2, and 2 divided by 2 is 1. We can already tell it's not going to be true because the 1 does not match the 2. But let's go ahead and figure out this other point, our y value, just to be sure. 1 plus a -2 is -1, divided by 2 is -1/2. So that does not equal to -1. So that's a way to show definitively, without a doubt, with numbers, that point O is not the midpoint of JB. Taking a look at number 3, point A with coordinates 3, 2 is the midpoint of CT, or segment CT, and point T has coordinates 5, 1. What are the coordinates of C? Okay, so it's giving us the midpoint and one of the endpoints, and it wants us to find the other endpoint. So let's graph these. A is at 3, 2. T is at 5, 1. So let's draw our label here just for space reasons. And what are the coordinates of C? Okay, so what we can do is figure out the y and x change from A to T, and then we can just copy that over to the left and up to find C. So C has got to be over here somewhere because A is the midpoint. So let's figure that out. The distance of the y's is going to be from 1 to 2, so that's a 1. So we're going to have to go up 1 from A to C, and from 5 to 3, well, that's a distance of 2, so we go left 2. So if we're at 3, 2, so let's do it this way. A is 3, 2, so we've increased our y by 1. So C, we're going to find C. We've increased our y by 1 because the difference between the 1 and the 2 is 1. So again, we're copying that x and y distance because the distance from A to T has to be equal from A to C because A is the midpoint. And we have gone 2 to the left, since 3 to 5 is two spaces, and we have to go to the left, 2 to the left from A to C. So we're going to subtract 2 from our original x. So then C is going to be 3 minus 2, which is 1, and 2 plus 1, which is 3. So 1, 3. And we got there pretty much when we were looking at it with our drawing. So that's the coordinate of C. And number 4, this is a Euclidean representation of midpoint. So point R is the midpoint of segment AT. Find the value of x and the length of AT. Okay, so we know that if R is the midpoint, then AR is congruent to RT because it splits it in equal pieces. They're both halves of AT. Similar to thinking of a segment bisector, because remember, segment bisectors have to pass through the midpoint of the segment. So we can set these two expressions equal to each other. 4x equals x plus 9. Now let's just solve this equation. Subtract x from both sides. That simplifies to 0. 4x minus x is 3x, and that equals 9. Divide both sides by 3. And x is 3. Now we found x, that's part of our question. We want to substitute x into the expression for AT. Well, AT is the whole thing, so we need to add 4x plus x plus 9 to get the value of AT, or the expression for AT. So that's going to be 5x plus 9. And we'll substitute our x value to find the actual length. So AT is 5 times 3 plus 9. So AT is 15 plus 9, which is 24. So 24 units. All right, that is it for midpoint, notes, and practice. See y'all next time.